Solve the polynomial 3k cubed plus 72k equals 33k squared. Here we are with office assistants Brooke and Sophia to tell us the latest on solving polynomials. When we solve polynomials, the first thing we want to do is set the equation equal to 0. If it's already set equal to 0, you can skip that. If it's not, you want to make sure that everything is moved to one side. Then you want to look to see if there are any greatest common factors that can be factored out. You want to check to see if all terms share a factor. Pull that biggest factor that they have shared, pull that out front, and then write what is left over inside parentheses. From there, you want to factor the polynomial. You may factor just the normal trinomial method, or you may have to do factor by grouping. Lastly, you're going to use what's called the zero product property. The zero product property says if you have two numbers, say A and B, being multiplied together, and that equals 0, we want to think, okay, what does that mean about A or B? Well, I know in order for something to equal 0 when I'm multiplying, I have to have one of those numbers be 0. So that means that A has to be 0 or B has to be 0. But that's the only way I get a 0 for an answer when I'm multiplying together, is if one of them is 0. So then we want to take this and we want to think, okay, what does that mean then? Is my A times B is 0. What if it's now 3x plus 2 times x plus 5 equaling 0? I still have two things being multiplied together and it equals 0. So just because now it doesn't look like it's just a number or a number that's 0, now we know that this whole thing has to be 0 or this whole thing has to be 0. So that's how we go about finishing solving a polynomial, is by using the concept that one of these must be 0. Thank you, Brooke and Sophia. Using that information, the first thing we have to do is set the equation equal to 0. So I have this equation equal to 33k squared. I need it equal to 0, so I'm going to move this to the other side by subtracting it on both sides. That's going to now leave me with the equation 3k cubed minus 33k squared plus 72k equals 0. The next thing that we have to do is factor out any GCFs that we might have. Looking here, all three of these terms have at least 1k. All three of these terms are also divisible by 3. So I'm going to pull a 3k out front, and when I do that, this is just left with a k squared. This middle term is left with an 11k, and my last term is left with only 24. From here, I need to factor my polynomial. So I have my GCF out front. I'm going to leave that out front. I'm going to then factor my polynomial that I have inside my parentheses. I know that I have a negative and then a positive sign, so I know that when I do my factoring inside my two sets of parentheses, I'm going to have two negatives. I'm looking for two numbers that multiply and give me 24, but that add to give me negative 11. So when I factor, I'm going to have 3k times k minus 8 times k minus 3 equals 0. I can double check because negative 8 times negative 3, and negative times a negative is a positive, and 8 times 3 is 24. But negative 8 plus negative 3, that does give me negative 11. So that checks. Now that I have factored my polynomial, now I use my zero product property. This says that I need to take anything that's being times together and set that equal to 0. So my 3k could equal 0, my k minus 8 could equal 0, my k minus 3 could equal 0. I'm going to finish this off by solving for k. Get k by itself here, I divide by 3. To get k by itself here, I have to add 8. And to get k by itself here, I have to add 3. So you can see I'm doing that to all three equations. That's going to leave me with k equals 0, k equals 8, and k equals 3. My final answer then has to be written in a solution set where my numbers are from smallest to largest. So I have the solution set of 0, 3, and 8.